Okay, so for my next part of this RC2014 project, I wanted to add some 8-inch floppy drives to it. Why 8-inch floppy drives? Older technology seemed more authentic to the project. It just seemed interesting, and why use this little tiny floppy disk when we could have these great big ginormous floppy disks. I went and I bought this from eBay for about $100. It was 2 Qume 8-inch floppy drives. I'm told these are sometimes, they're pretty hit or miss just due to the age of this this technology, that a lot of them have simply gone bad over the years, so I don't know if it actually works. But this is 2 full height 8-inch floppies in some kind of a case. I'm not sure if this is a custom case that somebody made or what it is. It does have a little plexiglass window on the top that seems kind of unique for the period. Looking at the back, so it's to understand, this thing is very heavy. I mean, it's bare to carry it up the stairs to the office. So looking at the back of it, it has a plug here for AC. Some kind of weird older plug. It did actually come with a cord. That's fortunate. Has a plug here for DC. It's going to take a 5 volt and 24 volt. It's actually called a Jones receptacle, and it will take a Jones plug. So I did actually buy some Jones plugs on eBay. Plug into there. That'll be our DC power. It is polarized via that pin, so it'll only go in one way. There's a toggle switch. Power it on and off. It's got this kind of cam lock thing up here. Holds the door shut. Inside here we can see the hinge is a little bit loose, but we can see that it has a fan, the Jones receptacle, the AC plug, and the power switch. Nothing fancy. There is no power supply in this drive, so we're going to have to come up with power supply on our own. I forgot how to get this thing out of here. I figured out that the drives, they mount from the bottom. We'll gently flip it on its end. Now, someone already removed a couple of the screws that hold the drives in, but I did figure out that these mounting feet, I believe, are holding the drive in as well. So I'm going to have to remove those mounting feet to get the drive out. Take a flathead screwdriver. If anyone knows where this case came from, if it's some kind of actual product, or if these things were some kind of homemade plan, I'd be curious to know. Seems kind of homemade to me, but it also seems like quite a decent homemade job, if that's what it was. Reasonable quality. So we've got the drive loose. Let's flip this over. Back. I think we can just scuff up the wall, push it right out of there. Ow. There's some more room. Soldering hood out of the way. So there, we have the 8-inch floppy drive out of the case. Piece over there, it's now considerably lighter. Let's see what we've got here. It's got a latching mechanism. You can get a good look at the front of it. I'm going to bring the camera in for close-up. Okay, so we're in a little bit closer. We can look here at the drive. You can see this is the clamping mechanism that's going to clamp down on the spindle. It's probably the index sensors for the track, so as the disc is rotating, it knows where the start of the track is at. There's a pair of sensors there. What else is to see? The head is down in here. The stepper motor mounts from the bottom side. Flip it around and look at the back. So here we can see this is a large motor that's going to be the spindle motor. It's important if you buy these that you get the right voltage. This is a 100 to 115 volt motor. You know, if you got the 230 volt motor, that would be good for you know, Europe and Australia, but here in the States we want the 100, 115 motor. There's a couple plugs. Here's the DC plug. Here's the AC plug. The stepper motor's over here, and there's this, it's called a steel band that goes back and forth and is hooked up to the head assembly. So if you move the head assembly, you can kind of feel the motor step. Feels reasonably smooth to me, though it's, you know, it's a fairly heavy stepper motor. Flipping it upside down. See, here's the bottom of the stepper motor. Stepping motor type KP6M2. We can see the bottom of the spindle. There's a rubber belt here that hooks the spindle up to the AC drive motor. It's a solenoid up here in the end. Move back so we can see that. Solenoid all the way up here. This is used for locking the door so you can't remove the disc. Got a controller board. Controller board visually looks to be in good shape. Of course we won't know till we power it up. There's lots of pins on here that select various things. So over here there's some drive select pins, terminating resistors, something in here that's been jumpered across. We're going to have to get out the service manual and see, you know, what these jumpers here and that jumper, what all this stuff means. But I think that's enough for us to probably give it a shot and try to get it figured out. Okay, I've got one of the two drives out. Now it's time to get the second one out. I believe I can get to it. Some mounting screws go up through the bottom. The easiest thing to get out of here. Jump floating around on the desk. Oops. One screw. Kind of a weird case the way someone designed it, that you have to take the bottom drive out to get the top drive loose. Most drives I've seen mounted have been screws through the sides rather than screws through the bottom, probably for this very reason. Okay, two screws are loose. They'll come out the front. It will. Okay. Second drive is out. Screwdriver out of there. Let's take a look at our second drive up close. Okay, so this one is a Qume DT/8. Let's get some space. From what I've read online, I think the DT8 and the 842, the previous drive we went through, are identical. I'm not certain of that, but it seems plausible. 70485. Check the serial number. Serial number on the controller board is different than the serial number on the drive. That could be a bad sign. Taking a look at it, most things look similar. Belt is intact. The same stepper motor. The two terminating resistors are removed. Jumper to drive select 1. I believe it's strapped the same as the other one. So if we look up a little closer here. So here we're looking at a close-up of the controller board. We can see there's this. So we can see there's this jumper block here. This is the way they did these. There's a total of 8 links in here, and to change the way the drive is configured, you cut some of these. And then in other places you install jumpers. So this one has a total of 3 of its pins cut. A jumper installed over here on C. And a jumper installed up here. I don't know what that one's for. We'll have to take a look at the manual and find out. But what I'd found out on the other board was they had it configured to do head loading from the connector and to run the stepper motor all the time. So maybe they've configured this the same way. We will find out. So next up, I needed to build a power supply since the 8-inch floppy requires 24 volts and 5 volts. You'll find some 8-inch floppies also require -5, but the Qume drives that I bought don't need -5. We only need +5 and +24. That simplified things a bit, so I put this together. This is a Jameco box. At least that's what I call them, as Jameco boxes. Get them from Jameco Electronics. At Jameco, they probably just call it a box. Anyway, it's a nice metal box, easy to cut out stuff. This here was a power supply, an open frame 24 volt power supply. It was a Meanwell, puts out 24 volts at, I don't know, like 3 or 4 amps or something. Tucked down here in the bottom, kind of hidden beneath everything else, is this is a 5 volt power supply. It's one of my LM2576 switching power supply boards that'll output 5 volt DC. So I have the 24 volt supply, runs out to a connector in the back, as well as supplying power to the 5 volt switcher module, and then the 5 volt switcher module also runs out the back. I put in a couple of fuses. You just unscrew. It's your regular glass fuse. One fuse for 24 volts, one fuse for 5 volts. Toggle switch to turn it on and off. An LED to show that the 24 volt supply is on. I drilled another hole for a 5 volt LED, didn't really get around to hooking that up. Here's your standard AC power inlet receptacle line filter thing. Makes it so I can use standard cords. I ran it out to one of these 4-pin plugs. I just happen to have some of these plugs from another project. Then ran it out to a cable, and then this hooks up to my Jones plug. So the Jones plug, I got these old Jones plugs off eBay. They're the right kind to mate to the plug that was on the back of the 8-inch drive enclosure. So that gives me a switchable 24 volt, 5 volt supply. Then I needed to make some adapters. So the PC floppy cable is 34 pins. It's a 34 pin header there. The old Shugart 8-inch floppy cable is 50 pins. And most of the pins, they map straight over in some way or another. You just have to know which ones go to which, and you can find the pin out of both connectors on the web. There's a few things you have to decide what to do with. So there's a disc change pin that can be hooked up to a number of places. So I
Left a couple of spots where that can be jumpered to, and then there's a head load pin, which you can run from various things. Some people hook the head load to the motor signal. I ended up hooking the head load via this little yellow jumper wire over to one of the unused pins on the PC floppy header. There's two pins that are unused, and then I ran my head load signal on that unused pin from my controller. So I'll make this board available on OshPark for anyone else that wants to do this, but you know, if you want to hook up an 8-inch drive to a controller with a 34-pin connector, you're going to have to either mangle up a ribbon cable or come up with a little adapter like this. The one signal that it doesn't deal with is the reduced write current signal. Some other people do make fancier boards with microcontrollers that are capable of determining when that signal needs to be applied and applying it at the right time. I'm kind of putting that off for a while, and I will try to come up with a way to do that from the controller to generate that reduced write current signal. So this board, the first one I made using pin headers, 34 pin header, 50 pin header. I always like to mark in red paint pen where pin 1 is, just so that you can never accidentally hook something up backwards. It's, obviously visible red there and there. Also made another one with card edge connector. I got these card edge connectors on eBay. This way you can just plug this, since the drives themselves have card edge connector, you can just plug this directly into the drive if you're testing a single drive. This kind of tricked me a little bit. You might notice the PC board is upside down. And the reason for that is, when I looked at the picture in the manual for the 8-inch drive, I thought pin 1 was going to be over here on the left, when I was actually looking at an upside down view of the controller board, which meant pin 1 was on the right. So this took a little bit of gymnastics here with the board to figure out how to flip things over and get pin 1 where it's supposed to be on the card edge connector. Then in order to get the 34 pin connector, I kind of had to hack it up a little bit, move it off, flip it over on the other side, and run the ground wire. I'm going to design a new board that actually has this connector reversed, so this won't be such an ugly mess. I also have the same little hack here for the head load signal. So those are the two adapters that I designed to make this work. Okay, I got myself some 8-inch floppies from eBay, Nashua brand. This is shrink wrapped, it's never been opened. Open them for the first time right now. See what's inside of here. One disc. And it comes with a sleeve. And some labels. Just for relative size comparison. So 3.5 compared to an 8. Okay, so it's time to try this out. I have the drive removed from the case. It's kind of sitting here backwards, so the disc slides in from this end. That's just so I can easily get to all the connections on this side. There is a floppy disk in it. So there's a latch release. See the floppy. Push the floppy in all the way. It'll kind of click into place, and then we can latch it down. Right now everything's powered down. I've got the RC2014 over here. My 50 to 34 pin adapters here with the 34 pin floppy cable hooked up to the floppy board on the RC2014. Let's start by powering up the drive. First we'll kick on the AC.
You can probably hear a whirring noise. That is the motor, which is now running. The motor, the AC motor appears to run all the time in this. So I don't know if it's evident on the video or not, but the disc is spinning, presumably at about 360 RPM. Let's kick on the low voltage. This is the 5 and the 24 volt supplies. There, that has lit up. Now let's power up my RC2014. It's over here. RC2014 is up. I actually do have it, in addition to the VFD display down here, it is hooked up to my laptop over there. Okay, hopefully you're able to see the VFD display. So we're booted to ROM WBW. Let's hit CPM. Now we're going to run the FD program. This is only a 4-line VFD, so you won't be able to see a whole lot on there, but hopefully you'll be able to see enough to gather what's going on. So let's run FD tool. It's got some options here. I need to hit setup, unit 0. We can select the format. We want format 05, which is 8-inch. No polling, no trace. First thing we're going to need to do is to format the disk. So I'll hit F, format the entire disk, interleave factor of 2. So we can see the head seeked all the way back. Now it's writing each track with the formatting information. So formatting puts an index mark at each sector to tell the drive, what sector is located as it's going over the track. So you can see here on the VFD it's counting up the tracks. I have it programmed currently to only do the first 40 tracks. That is because I haven't yet got the reduced write current signal figured out going to the 8-inch floppy. Reduced write current is used to reduce the current to the head past track 40. Until we get that figured out, we'll just use the outer 40 tracks. So that has formatted those 40 tracks. Now we will set up a buffer in the FD tool. Let's use a pattern. Just start the pattern so we can set the starting value of the pattern. I'll just set it to 33. So if we hit dump, that shows what we're going, well, it kind of scrolled by, but it shows a sequential pattern in the buffer that will be written out to the disk. So the next thing we're going to do is we will actually write this buffer. Let's do the entire disk. So now we can see it is writing out the disk. It's going to do 40 tracks, which is going to take a while. Okay, it has finished writing 40 tracks. Now we're going to use the verify option, which will read all 40 of those tracks in and make sure that it reads back the same data that was written. Verify entire disk. There it goes. So it seeked back to the start, and now it's going through each track one at a time. Okay, so it finished reading all 40 tracks. It read them successfully. That proves that the 8-inch floppy drive worked. If you've been watching my previous videos, you'll notice the RC2014 has undergone a couple of upgrades. It's got a VFD display, a new plastic case. It's running a different CPM distribution. I'm going to cover all that in a separate video. But let's get on with this video on 8-inch drives. Okay, so we're ready to start the demo. Everything's all put back together. Both drives are back in the case. The power supply is sitting up here. Out of the case comes a 50-pin ribbon cable. Out of the case comes a 50-pin ribbon cable. There's a 34-pin cable going to my floppy controller. In the middle here is the 34 to 50 adapter. Turned on the AC power. Let's turn on the DC power. Light has gone on. We've got power. Let's insert some discs. I've already formatted these discs using the procedure I showed you earlier. This is in. Both latches are latched. Okay, let's power on our RC2014. So over here, you can see the laptop. I'm going to try to screencast that in. The laptop's terminal is also shown on the VFD. The VFD is only 4 lines tall, so you can only see so much there. So let's boot to CPM. Still recording now. Let's boot to CPM. There's a clear directory command. That's how you initialize the directory structure of these floppies. So let's clear drive on drive C. Capital Y. That's the top drive. We can see its light is on. Clear drive on drive D. This should be the, let's see. Wants a capital Y. Clear drive on D. Bottom light came on. Let's start by copying a file to the top drive. Basic com equals basic so I'm going to copy Microsoft Basic to the top drive. You can hear the head seeking and loading and unloading and stuff. Go on to drive C, basic. There it is, basic loads from the floppy. Let's go back to drive B. Let's do an X modem receive. My standard demo is usually to install Zork. Zork2.com, receive X0. Oops, we want to make sure that's install it to drive D. Zork2.com. Let's transfer. Okay, so let's send Zork2.com. There, we see it started going. And there it flushed the disk. We saw the light go. Let's X modem d:/Zork2.dat. Transfer, send X modem. So sometimes it takes a little while for the X modem transfer to start. X modem is by nature a receiver driven protocol, so the sender's waiting for the receiver to send a start transfer signal, and it kind of errors waiting for the first block to start. So the second it ought to get going here. There we go. So it's transferring. This is a larger file, so it's going to have to flush the disk a couple times. First flush should be about a third the way through. There we go. Second flush about 2/3 the way through. And third flush. Okay, so we've received Zork. Let's just do a quick stat on these two disks. So drive C has 1108K free. Drive D 1034K, that sounds about right. Let's go over to drive D, Zork 2. Let's take lantern. Go south, 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 southeast. Oh, let's go south some more. How about southwest? There we go. South, it's dark. Oh no, what could happen? You died, you've been eaten by a grue. So Zork is working. So I think that's a pretty decent demo of the 8-inch drives. Happy with my eBay purchase. It has completed my retrocomputer project. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.